Now let us focus on this insertion sort algorithm. So what is insertion sort? The insertion sort works by building a sorted section of the array one element at a time. Let me repeat. Insertion sort works by building a sorted section of the array one element at a time by repeatedly inserting the next element in its correct position. Okay, sounds a bit difficult. So let me tell you what happens is that here you start from the second element of the array, and then what you do is that you compare it. Okay, you compare your second element with all those previous elements. Okay, and then what you do is that you do the swapping. All right, now you will understand how does it work when I will tell you the steps, and then when we will start actually implementing it. So insertion sort, all right, visualize. Okay, there is an unsorted array like this, and there will be a sorted array. So yeah, let me remove these steps now. Here what you will do is, start from the second element, all right, and then compare this element to the ones before it. You will compare the elements before it and insert in its correct position, all right, and now you repeat this process until your array is sorted. You do it with this, and then you go to this. Okay, it's 25. So before 25, compare with 34 and 64, and then you go to 12, and then you go to 22, like this. In this way, your array is sorted. Now let us implement this insertion sort algorithm. Here also the time complexity is O(n) squared. So function insertion sort. Const n equals to array dot length. So for let I equals to 1 means starting from the second element. Now let current element equals to arr square bracket I, and let j equals to I minus 1. Now this j will be used for the second internal iteration. Okay, while j is greater than or equal to 0 means as long as the index is not out of your bounds, and as long as this is greater than your current element, what you will do is that, see, you are swapping the position, and now you are doing j minus minus, means you want to move one position back to compare other elements, and here we set the value as the current. All right, that is how you do it, and then you return the array. So we will add the logs here basically, so that we can fully understand like this. Okay, so I'm running this. Now you see, compare with 64 and 34, compare with 64 and 25. Was moved here, and now comparing with 24 and 35. 34 and 25, and 64 and 12, 34 and 12, Now if it is not making sense for you, then let me add a debugger to show you how this all is actually working internally. So yeah, the current element is 34 indeed, and then this is 64. Okay, so this is indeed greater than the current. So the next element to it will be set as this, the current element, and here you see this j minus minus. Again we move, now the j is minus 1, so we come to here arr, and then j plus 1 means minus 1 plus 1 means the zeroth will be set as the current. Okay, next value was set as 64, the current value was now set as 34. Okay, like this. Now moving on to next iteration, here it is 25, and now again like this. Okay, so in this way what happens is this moved, and then you moved on to here and here, and now moving this and then moving and moving this, like this. The insertion sort will work. You see 64 34 and this 64 25, 34 25, and now 64 12. Okay, 34 12, right, and 25 12. So before 34 there was one element, before 25 there are two elements, before 12 there are three elements. So you are always comparing those. See, you are always comparing those. Okay, and this process will be repeated, and we will be moving our element to the correct position. Alright, this is how you can visualize your insertion sort, and this is our result: 11 12 22 25 34 64 90. That is how the insertion sort algorithm works in TypeScript.